Hey guys, the objectives for this video is to define a normally consolidated and over-consolidated soil. We're going to be defining the pre-consolidation stress, and we're going to be defining OCR, which is the over-consolidated ratio, the compression index, which is C subscript C, and the recompression index, which is C subscript R. Okay, so a lot of these words sound very fancy, but they're not so bad once we understand what's going on. So if we were to say in the ground, right, so I'm going to draw a picture, and we have a small element of soil. Okay, as we know, this soil has solid particles, we have water, and we have pockets of air. Okay, so what we can see is that this soil over time, this sample of soil, will be subjected to, say, deposition, right? So there's going to be layers of more soil forming on top of it, right? This is a diagram over time. More soil forms on top of it, which means that we're getting more vertical effective stress on our soil, okay? Which means that the voids ratio is going to decrease, right? Because there's more stress on the soil, it's going to force the water and air out of our soil sample, decreasing the voids ratio, right? So I can draw this with a graph. I can show this relationship. Okay, so we're going to do the effective stress against the void ratio. And we can show that as the effective stress increases, the void ratio decreases. Alright? This line is called the normally consolidated line. Okay, we say that our soil is normally consolidated. And what that means is that the maximum stress experienced in our soil is being experienced at the present time. So this line is obviously occurring over time. Over time, more layers build on top, and the stress will increase. So say this could have been 100 years ago, okay? But now, at this point, we're at time equals 0, okay? So at the present time, right now, the maximum stress we're experiencing is the stress we're experiencing now, okay? So the maximum stress is the stress we're experiencing now. That is the definition of a normally consolidated soil, okay? Now, what could happen is that these layers above our element of soil could be removed, like through a process like erosion or something, right? So these elements are now removed, which means that the effective stress on our soil is decreasing, okay? Now, just due to the nature of soil, what happens is that when this effective stress decreases, the voids ratio will obviously increase, but it's not going to increase as fast as this decreased, okay? So we have to go up a separate line, which has a smaller slope, okay? So the effective stress, because of the layers being removed, has decreased, and the voids ratio has increased, okay? But it hasn't increased at the same rate as this one decreased. It's on a different slope, okay? Now this line we call, this type of soil we call over-consolidated. Okay, the definition of over-consolidated is that now at our present time, so say we're over here at time equals 0, so we increased, then it decreased, so at time equals 0, the effective stress we're experiencing, so this would be that value down there, is not the same as the maximum stress we've experienced in the past, right? So that is the definition of an over-consolidated soil. An over-consolidated soil is when the present stress we're experiencing is not as large as the maximum stress we've experienced in the past, in contrast to a normally consolidated soil, which is that the present stress is the maximum stress. Okay, that is the distinguishing feature of normally consolidated versus over-consolidated. Now, we call this point here the maximum stress that the soil has experienced, the pre-consolidation stress, okay? I'll write that out, pre-consolidation stress. So that is the maximum stress the soil sample has ever experienced in its life. For a normally consolidated sample, that would be its present stress. For an over-consolidated sample, it would be beyond its present stress, it would be higher, okay? So that's what the pre-consolidation stress is. What could happen again is that we could reload the soil. So from our time 0, now let's say we're getting deposition again, okay? So we're getting an increase in effective stress, which means that we'd come from our time 0 back along this line, okay? And once we get to our pre-consolidation stress, we come back onto the normally consolidated line, okay? So we continue there along our normally consolidated line. Okay, so the important thing is that we can never go up our normally consolidated line, we can only ever go down. But that's the process of what would happen. We would say load the soil, get to a point, unload the soil, get to a point, reload the soil, come along this same line, get back to our pre-consolidation stress, and then continue along our normally consolidated line. Okay? We're going to see in the next couple of videos, I'm going to show you all the different types of questions you can get based on this graph, like finding when you increase the effective stress, how the void ratio changes. We're going to develop some equations. Just another two things before we finish. We call the gradients of this line, of the normally consolidated line, the compression index. If you want to think about it, it's very simple. Because it's being compressed, it's just called the compression index. So this gradient is called C subscript C, which stands for the compression index. The gradient of this line, the over-consolidated line, is the recompression index. So C subscript R, that's for this line here. And the last thing we need to define is the OCR, the over-consolidated ratio, which just equals the pre-consolidated stress over the initial stress. Let me just double check that. One sec. Yeah, okay. So the OCR is the pre-consolidated stress over the initial stress. The only reason I'm giving you this definition is sometimes in questions they give you the OCR. You'll see what I mean in a second. So if you understand all this, then you're doing well. In the next couple of videos, I'm going to just, as I said, show you all the different examples of questions you could get based on this type of graph and the information you could be given. I hope that helps, guys.